So apart from knowing that they exist, what do astronomers have to learn from observing these neutron stars?
Well, neutron stars, as I said, are the end products of stellar evolution. And so it gives us a little more insight into, the start to end process, the life cycle of a star. Neutron stars, of course, are also pulsars. If we've got the right orientation, those intense objects, intense from a gravitational field perspective, are also intense from a magnetic field perspective. And they can, with the right environment, sweep a beam of radiation across the Earth on a really, really regular basis. The Crab Nebula, for example, has got one of the brightest pulsars in the night sky, and it's sweeping across us, 30 times a second. So when we're seeing pulsars, that gives us more insight into the magnetic field composition that is associated with those stars. It talks to us about, as I said, the end state of a stellar evolutionary process. So learning more about neutron stars, and now, of course, with gravitational waves being detected, neutron stars merging with white dwarfs, neutron stars merging with black holes, and so gives us another insight into these particular objects and what they can do with during the merger process. So I think of the universe very much like a jigsaw puzzle. If you've got a 1,000 piece jigsaw puzzle with every single piece face down, every object in the universe, every wavelength band in the electromagnetic spectrum represents a piece of the puzzle. And so you turn over that piece of the puzzle, hoping to gain insight into the picture as a whole. The only problem is we don't know what the picture looks like. Like a regular jigsaw puzzle, you've got a photograph there and you know what you're working towards. In our case, in astronomy and astrophysics, all of the pieces are face down and we're not real sure what the final picture looks like. We've got ideas, but we're not certain. And so neutron stars and their analysis, just another piece of the bigger puzzle that talks to us about the operation of the universe.
And the
And
bigger puzzle might be infinite as well.
Probably is. Yeah, 1,000
exactly.
pieces mightn't be a big enough puzzle. It might be
Yeah.
10,000 pieces. Hey, I think of it as job security. Okay, I mean,
But
if we
talking about like the infinite puzzle, right? Like I was just wondering, and I was just like looking up these questions, before like we had this conversation here, and I was just and a very common question was, and something that I was just continuing to think about is, can we ever estimate the true size of the universe? Because we are constricted by the observational universe, right? And we can estimate it to a very reasonable degree. Obviously it's not exact because it keeps increasing, but we can estimate it. But my question is, do you think we would ever be able to, like humanity as a civilization would ever be able to estimate the true size of the universe? Or do you think it's just infinite?
if we really do believe that the speed of light is the ultimate speed limit, I think the answer has to be no. We'll never really know. You will be able to develop theories, models that you can test experimentally and have confidence that the predictions of your model suggest that it is this big. But because we have been we're existing 14 billion years ish since the beginning, since the Big Bang, and because the expansion rate is occurring, and because we're limited by, as you say, the horizon, the speed of light, we never really will know for certain the extent. And that's putting aside the question of multiverses. I mean, are we the only universe that is out there? Perhaps the only way we will ever really know is if, in fact, an old theory, which we don't believe is true anymore, if we're eventually going to stop expanding and begin to contract back towards a big crunch, if we're in an oscillating universe. Now fast forward here tens of billions of years, guys, because this is not going to happen anytime soon.
Mm-hmm.
But I guess technically we could, if we are in a collapsing universe, we could, quote, determine the extent of the universe if we're in this oscillating big crunch type scenario. But that, to the last I heard, cosmologically speaking, that is not believed to be the correct analysis, the correct state of our universe. We do think we're in a continually expanding universe. And if that is really the case, then we will not necessarily know the true extent of our universe.
And does that have any significance in terms of the mass density of our universe? If it just keeps on expanding, eventually, like the yeah.
Well, back 20 years ago, we thought the critical density of the universe was really important to try and determine whether or not we were in a forever expanding or a just expanding, or indeed, the crunching type collapsing universe. The critical density of our universe was really, really important. Given the findings associated with dark energy and the repulsive force that is associated with dark energy, then the critical density of the universe, as I understand it, remember, I am not a cosmologist, okay, but as I understand it now, dark energy has overwhelmed the concept of the critical density. There is now simply not enough matter in our universe. Even when we start factoring in dark matter, dark energy overwhelms that and continues to push outwards. So I don't think critical density, total mass of our universe, is nearly as important as it once was, as I said, 20 or so years ago, when we weren't aware of dark energy.
If I'm not mistaken, dark energy, because I'm actually not too sure about this either, but dark energy, is that continuously created and is expanding the universe? Like, how do we believe that the universe is expanding via dark energy? Do we believe that more and more dark energy is being created and therefore expanding the universe? Or like, what is the exact, or like, I guess we don't have an exact answer, but like, what is the estimated answer that we have for why dark energy is expanding our universe?
Okay, so I'm going to put the caveat here. You need to speak to one of my colleagues who deal with this sort of stuff, because this stuff keeps changing. When I went to university, none of this stuff existed. So I've been learning it like you on the fly. Okay.
I understand.
But dark energy is associated with the vacuum of space, and it is an intrinsic quantity or an intrinsic quality associated with space itself. Unlike dark matter, which is getting diluted as the universe expands. The quantity of dark matter we don't think is increasing. And so as the universe gets larger and larger, the density of dark matter is going down. Read that to mean that dark matter was much more important when the universe was younger and therefore smaller. Okay. And so we are no longer living in a dark matter dominated universe, whereas in the past we were. We are now living in a dark energy dominated universe. About, if memory serves, something like 67% of the matter energy balance is associated with dark energy. And that's what's propelling the expansion process. Whether or not dark energy is increasing because the universe is increasing in its size, I believe that is true. But I'm going to stop there, because I'm going to have all of my theoretical cosmology guys all over me going, no, you don't know what you're talking. And I don't really. Okay. But the matter energy balance in our universe, 67% is dark energy. That now dominates the processes. Locally, in and around galaxies and galaxy clusters, dark matter is far more important because, the gravitational properties of dark matter. But when we're starting to talk about cosmological scales, dark energy is the dominant characteristic, and that is pushing us outwards at an increasingly rapid rate.
I was reading somewhere that, and this is, I think, the craziest thing that I have ever read, that dark matter, now listen to this, dark matter could be gravity from other higher dimensions. And I read that, and I was just like, wait, what